most famous question which gets asked in the interview. How the hash map functions. Or state the internal implementation of HashMap. This is one of the most famous interview question, especially when you're giving the interview related to Java. So now basically what happens is, let me explain you one. So you guys are aware, right? Retrieval normally takes, on an average case, takes big O of 1 time complexity whenever you're searching any values, right? So what is the use case of HashMap? That search becomes very efficient in HashMap. Why? This is because you can basically return that value in big O of 1 time complexity. So now you need to figure it out that how basically the hash map works, that it returns the values in big O of 1 time complexity, correct? So let's say if you are given an array, let's start with the array data structure, correct? Let's say you're having mango, apple, potato, rice, and let's say dal. So if you will see 0, 1, 2, 3, 4. Now let's say if I'll ask you search for rice, correct? So what will happen? The worst case time complexity is going to be it needs to iterate through each and every index that is there into this array, right? So in the worst case, what is going to be the time complexity? The time complexity will be big O of n. Let's say if I'm asking you to search banana, the banana is not there. So in the worst case, what is going to happen? It is going to take big O of n time complexity, right? Because it is going to search in your entire array. Make sense? Now let's say what is going to happen is, if you say that, okay, I know that if the position of dal is over here only, dal is at a specific location. So in case of hash map, what happens is I will have a map, and what I will do, I will store dal over here as a key, and I will keep the index location as the value. Now, if you want to search for this specific key, right? So what you can do is simply use map of dal, and whatever value it returns, right? So this will be the value that you are ultimately returning, which is 4 over here. You are pushing the value of key and you're getting the specific value, correct? So now what is going to happen is, so now in this case, you know that, okay, it is returning the value instantly because at that specific key location, this value is getting stored. So now let's say, I can say that, okay, I'm going to have, let's say, how many numbers? So basically the array has capacity to, let's say, store 10 to the power 5 numbers, right? But let's say if I'm having something called million records, just for an example, correct? So in that case, what is going to be the size of the array in that case? You cannot have million size of the array to store these million records. Are you getting my point? So this is where hashing comes into the picture. So basically, hashing, what it consists of, you have different buckets. So let's say you're having 15 buckets over here. Rather than keeping it as horizontal, let me keep it as vertical. This makes sense to you guys, right? So 0, 1, 2, 3, 4, 5, and dot, 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 dot. You're having, let's say, 15 over here. So over here, if you will see, size of bucket is equals to 16, correct? So there are 16 bucket into your hash map. So now basically what happens is, whenever you're inserting any certain element that is there, let's say I'm inserting banana over here. So first of all, what is your target? You need to put this specific key into the specific bucket, right? So what happens is this banana is getting pushed into a hash function. What is this? This is a hash function. When you're putting this banana into the hash function, it will return you certain number. Let's say 29. Now what you will do, can you put this 20 into this bucket? It's possible, right? Because 29 is greater than 60. That means it will be out of bound, correct? So in order to put 29 into this bucket, what you do? You will do 29 modulus 16, which will be equals to 13. So as a result of which, what you are going to do? You are going to put this banana to this bucket. So add banana over here. Does this thing make sense to each and every one of you? So now basically, whenever you will be searching, retrieving the data banana, correct? You will say that, okay, I need to retrieve this data where it is stored. So what it will do again, whenever you are searching for map banana, right, it will return the specific value. So in hash function, whatever key you give, it will always return you the same value. So in this case, it is going to return 29. And how you will figure it out in which index location? Take the modulus of total number of buckets which is there, which is 16. So 29 modulo 16 will be equals to 13 over here. Makes sense? So and then you will come at this bucket location 13 and you will see that, okay, banana is stored over here. So this is how you are able to efficiently retrieve the data. And this is how HashMap functions internally. So is this thing clear to each and every one of you till this point? Anyone having any doubt somewhere? If it is clear to you guys, you can respond with yes. If anyone has any doubt, slightest of doubt somewhere, don't hesitate to ask me. Feel free to ask me. Because this is very important for you guys to understand. Yeah, tell me.
Ranjan, suppose the size of the hash map is increasing, what will happen? I mean, this 16 won't be a constant, right? It will get changed, no?
No, the size of the hash map, you need to keep that constant, right? So depending on the hardware, right, it needs to get decided that, okay, what is the size of the bucket? So in case you need to increment the size of the number of buckets which is there. So basically, hash map, how the size of the hash map is getting decided, it is getting decided with the buckets that is there, right? So let's say if you're having more and more number of inputs, so depending on the situation, if you might need to increase the number of buckets, so again, you need to leave it to the OS or the hardware to decide that, okay, how many number of buckets that needs to be incremented. But generally, whenever you are declaring the hash map, right? So beforehand only that gets decided that, okay, now this is the size of the buckets that I need to allocate to this hash map. Does
No,
this
when
thing
we
make sense to
initialize,
you?
I mean, when we initialize the hash map, it will be initialized with a certain size, right? So once that size
Yes.
is crossed, it will be increased again. So in that case, I'm asking that size will get changed, right? I mean, or it will be always the hash function will be calculated with some certain size that is configured. I mean, depends on the OS configuration.
Yeah,
So
Ranjan,
basically,
I mean, this happens when, let's say, there are 10 server and one server is not responding. So now we have 9 servers, so all the requests have to get into those 9 servers only, right? So how do we handle all those?
yeah. So I'm getting two of your points, but I think I'm getting you. So the second question, which is asked to me, right? It is related to the system design. I'm going to definitely answer that question as well. And related to the first question, which is getting asked to me, right? So what happens is the size of the hash map, it can be changed. But the thing is that what happens is initially when you declare that value, so number of buckets that is going to be there, right? It it is first of all pre-decided. Now, if you are stating that, okay, now you need to increase the bucket. So what happens is, let's say if there are more number of collisions that is taking place. So this is one such example. Let's say we have got banana. Let's say I'm bringing mango. Now when I'm bringing mango, again, it is returning 29. So what will happen? There will be a chain of linked list which will get established if it is falling to the same index location. Are you getting my point?
Yes.
So, so basically, if there is a collision that is taking place, right? So obviously you are having a linked list, and that linked list will basically take care. Okay, when a new keys are getting added and it is getting allocated to the same bucket, so it will get incremented in that linked list style for that same bucket. Now, if you are basically trying to change the map that is there, right? The number of buckets that is there. So in that case, again, either it would majorly depend on the OS that, okay, if it is capable of increasing, because it would be needing that many resources, right? So at the time of declaration only, it decides that, okay, how many number of buckets it need to choose. And let's say, as you're stating, if the records are continuously increasing, so if the records will increase, then what will happen? In that case, the collision will take place, right? And obviously for that, the collision handling, we have a linked list present, right? So just like I explained, let's say mango is coming. It is again getting 29 number hash function, and it is coming to index location 13. Let's say banana will come. Again, banana is already there. So now let's say orange will come. So basically, if it is falling at the same location, so basically, if you will see, right, the linked list gets formed at this point, right? So
Yes.
even if the number of records get increased, So the thing is that if the buckets is pre-decided, so I'm not saying that it cannot change. It can definitely change, right? And again, it depends on the programming languages that is there, right? Or the library which you are using to understand that, okay, how the hash map values gets changed. But normally what happens is whenever you declare the hash map, let's say hash map integer map is equals to new hash map, right? So it's then only the size of the bucket is getting decided. You're getting my point? So it again depends on the programming languages. As I stated, it depends on the programming languages OS. So whenever you are declaring the hash map, right, at the time of creation or initialization, only the size of the number of buckets gets prefixed.
Okay. So
And
because
if
I
yeah,
read something like once the hash map is full means it will be increased, the size will get increased automatically. So I mean in such cases, okay, that will be handled by linked list.
if the number of records are increasing, but let's say if your hash map that you are doing, right, it allows dynamic resizing, correct? So it again depends on the programming languages, right? So if it allows dynamic resizing, then in that case, what is going to happen is it is going to automatically adjust the size of the hash map depending on like different factors that are there. That okay, the number of elements or the load factor. But this is one such scenario where let's say if you're having more and more number of elements, right? It can get mapped to the same index location with the help of linked list. But then again, depends on the programming language, depends on the OS, that if it allows dynamic remapping of the dynamic mapping of the hash map that is there, right? So in that case, the number of buckets allocated can increase or decrease, right? So, but it again depends on the certain criteria that okay, can increase the number of buckets that is there, and then you need to have whatever the existing key is there, because again the number of buckets has got increased. Again, it depends on the programming languages as well as the libraries which you are using to implement your hash map. But normally what happens is hash map size are fixed, and like it normally changed after the initialization. Just like we see in coding, right? So let's say in coding, whenever you initialize the hash map, so that you simply process it, right? Or during your logic implementation, you change the size of the or size of the bucket. Do you ever deal with that while coding?
No, we don't.
You don't do that, right? So that's why.
Yes.
So that's why the thing is that, as I stated, so it depends on the OS, it depends on the programming languages. So I'm not saying that it is hard and fast rule, it cannot be applied, right? But again, it depends on the OS thing, depends on the programming languages, that whether it allows or not, whether the hardware is capable to handle those. Because again, all these things will get stored into your memory, right? Into your main memory, into your disk. Are you getting my point?
Yeah.
So these all are the reasons that okay. So again, as I stated, you cannot say that okay, the size cannot be increased, the size cannot be decreased. Normally, it happens is that whenever you declare, as I stated earlier also, whenever you declare the hash map, during that time only the size gets decided. But if your programming language or the library that you are using for your hash map, right? If it allows resizing your hash map, then obviously the number of buckets can get increased or decreased. No worries on that part. Now to answer, I think the second question which you asked me, right? If the resizing takes place, then in that case, we are dealing with the size of bucket over here, right? What is the size of the bucket? 16. So let's say 29. Let's say now I'm increasing the bucket. Now my total number of bucket is 18. So in which index location it will fall? What is the value of 29 mod 18? It is 11, right? So it will fall now in index location 11. So this is how resizing basically needs remapping. So did I answer both of your guys' question? Is it clear to you guys that why remapping takes place? If we are increasing or decreasing the size of the bucket, because the modulus function gets changed, because the total size of the hash map gets changed. That is the reason. Does the thing make sense to you? Anyone having any doubts or concerns? Niharika, Nirmala, is it clear to both of you?
Yeah, it's clear, Ranjan. But does it have any cons like this kind of restructuring?
Yes. There's a cons actually, and let me explain you. This is actually a concept of system design. I think your system design tutor should definitely cover this because it is very important. That's why let's say bucket size. Let's say you are taking in place in terms of server. So just assume that okay, number of server is equal to number of bucket. This thing I'm explaining in terms of system design. So basically what happens is, let's say you have 4 servers that is there, right? And let's say where whatever number hash function is generating the number, you are taking modulus 4. So as a result of which it will fall in, let's say 0, 1, 2, 3. Now let's say one server gets down, as a result of which you are having only 3 servers remaining. So now what will happen is, initially 29 mod 4, what was the value? 29 mod 4, it is 1, right? But now you will do 29 mod 3. What will be the value in this case? It will be 2, right? So obviously all the values which was located in different server will get remapped now. So as a result of which remapping, large number of remap take place. And when you are doing remapping of the data, right, in that case, your data are not available to serve it to the user or the client who are asking for the request. As a result of which your availability, it impacts the availability of your system. Are you getting my point? So that is why in order to avoid this hashing, you should go ahead with consistent hashing. So in consistent hashing, what happens is, let me explain you that trick also pretty quickly. I think that should be covered in the system design as well. So let's say what happens. This is your server. And this is your server, correct? So let's say any number 2, 3, 4, whatever number falls over here, this is getting allotted to this server. Any number bullshit comes over here, it gets allotted to this server. Any number comes in this region, it gets allotted to this number. Are you guys following me? Any number, hashing number which comes in this region, it gets allotted to this server, correct? Now what happens is, let's say this server dies. So as a result of which, when this server dies, all these number which was getting allotted to this server now, right? Now all these number will need to get allotted to this server. So as a result of it, this server might get overburdened with lot of requests. Are you getting my point? So there is a chances of that, okay, this server is getting a lot of requests, so this server might get down or might have to implement throttling or rate limiting to basically limit a certain number of requests. Otherwise, it is going to impact the performance, right? So there is a chance that this server can become the hot server. So as a result of which, in consistent hashing, what we are doing is we create a replica of it, each and every server. So in consistent hashing, what happens is, so let's say this is your server 1A. Now let's say this is your server 1B. Now let's say this is your server 1C. You are creating different instance of this server. Are you guys able to follow? This is your server 2A. This is your server 2B. And this is your server, let's say 2C. So now let's say what happens if this server dies, 2C dies, right? So the thing is that if 2C dies, so in that case, whatever numbers are there in between, it is going to get allotted to the next server which is present. But since you have a huge amount of replica present, right? So there will be less number of requests which will get routed to the next server. And as a result of which whole server doesn't die, 2A and 2B still exist. Are you getting my point? So as a result of which, in consistent hashing, even if any server gets down, right, lesser number of remapping takes place. So this is the advantage of consistent hashing. Are you guys able to follow that why we are using consistent hashing over hashing? Because
Yeah,
if any server dies or any new server gets added, minimum number of remapping takes place. Otherwise, in case of hashing, if large number of remappings takes place, which could be a bottleneck for the system. So this is how consistent hashing avoids that. Does this thing make sense to each and every one of you?
yes. Yeah, thank you for explaining.
And I think this should be covered in your system design as well, because this is one of the important concepts in the system design.
Okay.
So yeah, anyone having any doubts or concerns in whatever we discussed till now?
Clear, Ranjan.
Yeah, no.
So this is all about, this is the, like from the coding point of view, I think this was the first page which I stated you, right? This is very important. Like you need to understand that, okay, hashing is basically used to store key value pair. And depending on the question, sometimes you need to store value as an index, or sometimes you need to store value as some counter frequency that you are using. So depending on the question, that it varies. And how HashMap internally gets implemented. This is the most famous interview question. That's why I explained you guys. And again, how basically collision takes place, how collision gets resolved via linked list, even that has been explained. And from the system design point of view, how hashing could be a bottleneck, and how consistent hashing comes into the picture and solve that issue. So we have covered all those two things. So anyone having any doubt or concerns? If yes, feel free to ask me. Otherwise, we'll start moving towards our first problem. So this is all about the hashing data structure, which you guys need to know and understand.
We have got tension. We can go for question.
Perfect. That sounds good. So in that case, let's move towards the first question then. So you are given an array of integer nums and an integer target. You need to return indices of the two numbers such that they add up to the given target. You may assume that each input would have exactly one solution and you may not use the same element twice. So you can return the answer in any order. So let's say if you have input array as 3, 2, 4 and your target is equals to 6, your output should be 1 and comma 2 because 2 plus 4 is equals to 6. The question clear to all of you? Anyone having any doubt in the question? Okay, so if you don't have any doubt,
So in the question, as per the question, like we cannot add first and the last element, right? It should be in a
why you cannot add?
consecutive.
You can add first and the last element. Why can you cannot add first and the last element?
Like if
You
we add,
cannot use the same number twice, but obviously you can add
Okay.
first and the last element if that leads you to the answer. Let's say if your target is 7. So in that case, you can have 3 plus 4 equals to 7, right?
right.
Yeah, there is no such
So
restriction.
if the element is we have a hash map, and if the element is already existing in the hash map, sorry, we search for the complement. I mean, here our target is 6, right? So
Exactly.
if if our current element is 2, we search if there is 4 in the hash map. If we don't have 4, and if we don't have our current element 2, we add the current element.
You're absolutely correct. So that's why let me explain with the help of this proper example. Let's say you have 16, 4, 71, 8, 69, 3, 50. Correct? So let's say this is your array which is given to you, correct? And let's say your target is equals to 85. How will you reach 85? Or let's say your target is equals to 73. How will you reach 73? 4 plus 69 is equals to 73, correct? Now basically what is going to happen is, so let's say you are having fifth map of 16 is equals to 0. So what you are doing over here is you are basically putting the element as a key and you are putting the index as a value. Are you able to follow this? So let me explain this with the help of this example. Map 16 is equal to 0, correct? Now the thing is when you are coming to map 4, so you will check that, okay, if map of what is your target? Your target is 73. 73 minus 4. What is 73 minus 4? It is equals to 69, correct? If map of 69 is not equals to null, so in this case, this one is not equals to null, right? So if map of 73, map 69, does it exist? No, it does not exist. So it is null over here. So map of 69 is equals to null. So since it is equals to null, so in that case, what you will do? You will not do anything. You will simply put map of 4 is equals to 1. Now, basically, what is the next step? You will check map of 71. So 73 minus 71, 2. Map of 2 exists? No, it does not exist. So what you will do? You will put map of 71 is equal to 2. Now, in the next case, what you will do? 73 minus 8. What is the value 73 minus 8? Whatever, 65. Map of 65, does it exist? No, it does not exist. Simply ignore it. So what you will do? Map of 8 is equals to 3. Now what you will do? Map of 69 you are getting, right? So what is 73 minus 69? 73 minus 69, it is equals to 4. Does this exist? You will say, yes, yes, yes. Map of 4 exists over here. So in that case, since map of 4 already exists, so you know that yes, you will get 69 from this element. 4 already exists. So now you know that 69, this whatever, what is the value? So currently you are at index location I, right? One index location will be I and the other index location will be map of target minus ARR I. So these two are your index location, which is leading you to the given target, which is leading you these two number gets added and it leads you to the given target. And you need to return this. So is the approach clear to you guys? So over here, you need to focus that what you are using as a value and what you are using as a key. In this case, the important trick to understand is that you are using the element as a key and you are storing the index as a value. Now you will ask that, okay, why I am using index as a value? You are using index as a value because you need to identify those two numbers whose sum is equal to the target. Obviously, one approach would be to use the nested loop. But in this case, since you already know the target, right? So let's say if you are having x plus y is equals to 69, just for an example. So in this case, what I am doing, in order to find x will be equals to nothing but 69 minus y, right? So what you're doing, you're simply checking that, okay, if this y exists or not. Are you getting my point? So if it already exists, if you have already computed, then you can easily compute x also. So this is how we are computing this. So simply check if target minus array element already exists into your map or not. If it does not exist, simply put that element as well as index location. If it exists, then you are at current index location I, and from your map you can get the next index location and then simply return these two values. As simple as that.